Hi everyone. Today I want to go through question 3 from the booklet. This question is from November 2017. The question starts as, the vapor pressure versus temperature graph below was obtained for 4 straight chains, which are unbranched alkanes. They are P, Q, R, and S compounds. From P to S, each compound differs from the previous compound by a CH2 group. So they are all alkanes. The difference between them, each one has one extra carbon and 2 hydrogen atoms, one extra CH2 group. Give a reason why alkanes, 3.1, give a reason why alkanes are said to be saturated. Remember, we have saturated and unsaturated compounds. For a compound to be saturated, what we say, if it has only single bonds between carbon atoms, then we call it a saturated compound. Single bonds between carbon atoms. Only single bonds. Or you may say there is no multiple bonds between carbon atoms. That's why it is a saturated compound. Define vapor pressure. Vapor pressure, guys, forms when we have a liquid. The liquid starts to evaporate and it forms vapor on top of the liquid. These vapor particles start to create a pressure, and this pressure, this vapor with the liquid forms an equilibrium. So that as a definition we say vapor pressure is the pressure exerted, let me write it here, I can choose a different color, pressure exerted by a vapor in equilibrium with its liquid, and this happens in a closed container. So we need to add here in a closed system. So the definition goes as pressure exerted by a vapor in equilibrium with its liquid in a closed system. The next question, use the information in the graph above to answer the following questions. What is the effect of an increase in temperature on vapor pressure? Choose from increases, decreases, or no effect. The effect of temperature on the vapor pressure. When you look at the graph, you can easily see this. When we increase the temperature from 0 to 20, you see there is an increase in the vapor pressure. So the correct answer is increase. As you increase the temperature, the substance starts to evaporate more, so that more vapor particles will be present on top of the liquid, so that it can create more pressure. So an increase in temperature increases the vapor pressure. Which compound, 3.2.2, which compound has a boiling point of approximately 68 degrees Celsius? Give a reason for the answer. Boiling point, guys, is the temperature where the vapor pressure equals to atmospheric pressure. Whenever the atmospheric pressure and vapor pressures are equal to each other, at that temperature, a substance starts to boil. So here we need to look at which graph or which substance reaches to the atmospheric pressure at 68 degrees Celsius. This is 60, that line should be 70. So 68 somewhere here, just close to this 70. I extended graph like that, and you see this substance, which is substance Q, compound Q, has a vapor pressure equals to atmospheric pressure at 68 degrees Celsius. So the answer is compound Q. The reason is at 68 degrees Celsius, vapor pressure of substance Q equals to atmospheric pressure. Is that clear? The next one, which compound has the longest chain length? Fully explain the answer. All right, now we need to find which compound has the longest carbon chain, and we need to explain this. You need to refer to the graph and take a random temperature, let's say 40 degrees Celsius. At 40 degrees Celsius, as you can see, compound S has the lowest vapor pressure and compound P has the highest vapor pressure. We know that vapor pressure is inversely proportional to the boiling point. That means substance S has the highest boiling point. As substance S has the highest boiling point, that means substance S has the strongest intermolecular forces. And those compounds are all alkanes. And you know that alkanes can only form London forces. The strength of London force depends on the surface area and the molecular mass. If compound S forms the strongest London forces, that means compound S has the largest surface area as well as it has the biggest molecular mass. So that the answer will be S. So how we explain that? We simply say compound S has the lowest vapor pressure so that it has the highest boiling point. As it has the highest boiling point, it has the strongest intermolecular forces. You can mention London force as well. It has the strongest London forces. That needs the highest amount of energy. Then you can say the strength of London force depends on the surface area and the molecular mass. As the compound S has the strongest London force, that means it has the largest surface area or longest chain length. That is the answer. All right. Let me erase all this. And question 3.4. Compound P has 5 carbon atoms. Draw the structural formula of chain isomer. These isomers are an important concept in organic chemistry. As you see, you will see very often these isomers in the test. So better to learn it very well. Chain isomer. I mentioned the other day, structural isomers are the organic compounds with same molecular formula, but different structural formula. Different structural formula. We have 3 types of isomers. The first one is the chain isomer. In a chain isomer, the molecular formula is the same. What is the different one? The different one is the chain structure. Chain structure is different. So to make a chain isomer of compound P, we need to make the chain different than chain of compound P. Initially, it was said all these compounds are straight, unbranched, so that compound P is a compound with 5 carbon atoms on a straight chain. It's like that: CH3, CH2, 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 and CH3. That is my compound P. This is called pentane. What I need to do to make it a chain isomer, I need to make this straight chain a branched chain. So the chain isomer of P has to be either CH3, you can make one branch here, and H, CH2, CH3. That is, sorry, it's same structural formula, right? So I need to just correct this. I wrote condensed structural formula. So let me just erase this. Okay, I go back. P is CH3, CH2, 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 and CH3. So its chain isomer has to be a branch here, and we have 4 carbon in the chain. So I had here the hydrogen atoms. That is one of the possible options. Actually, we have 2 possible chain isomer. Now I'm going to write the second option as well. You can go either one. You can go with either one. This is one of the possible options. The second possible option, you can make 2 branches on the second carbon, just like this. C, here we have a methyl group, and I make another methyl group. And my 5th carbon goes there. Here we go. So the chain isomer of pentane can be either compound 1, I wrote up there, or compound 2. These are the structural formulas of chain isomers of compound P. As it's asked in the structural formula, I wrote the structural formula, and here you need to look at here. It says write the IUPAC name as well. So for the first compound, the IUPAC name is 2-methyl butane. We have 4 carbon in the longest chain. And the second one, we have 3 carbons in the longest chain, and I have 2 methyl groups on the second carbon. So it's going to be 2,2-dimethyl propane. Yes, you can choose either option and write it as an answer. But you don't need to write both. Okay. And the next one, how will the vapor pressure of this isomer compare with that of compound P? Vapor pressure of this isomer, let's say the first one or second one, doesn't matter, in comparison to the vapor pressure of P. You know that vapor pressure is inversely proportional to the boiling point. So we need to look at the boiling point. And boiling point is directly proportional to the intermolecular forces. These compounds are all alkanes, and they are nonpolar. They can only form London forces. They can form only London force. The strength of London force depends on molecular size and the molecular mass. As a compound becomes more branched, it becomes smaller. The surface area of a branched molecule is smaller than a straight chain. I can write here, branched chain as a smaller. This is a general rule. Always a branch chain has a smaller surface area than straight chain. The more the branch, the smaller the surface area, which means compound P has the biggest surface area. Compound 1 is smaller than P, but it has a larger surface area than compound 2. In between those three compounds, compound 2 has the smallest surface area. That makes compound 2 form the weakest London forces, so that compound 2 has the lowest boiling point, while compound P has the highest boiling point. So here we can say the isomer of this compound has a lower boiling point than compound P, which means it has a higher vapor pressure. That is the reason. All right, thank you so much for listening. I'll try to add another video the next day. Bye-bye.